Welcome! In just 3 minutes, let's break down the sodium-potassium pump, the cell's way of staying balanced and energized. Phospholipid bilayer is a selective permeable membrane, also known as a semi-permeable membrane, that's a barrier allows some substance to pass through while blocking others. This selective passage is crucial for maintaining the integrity and function of cells and other biological systems. This is the plasma membrane earlier and some of the components involved. Sodium-potassium pump has two specific binding sites, which are ion-sodium binding sites and ion-potassium binding site. Inside the cell, potassium ions are high compared to sodium ions are low. Meanwhile, outside the cell, sodium ions more high than potassium ions. This is a summary of the sodium-potassium pump that goes in and out according to the difference in concentration between the outside and inside of the cell. So, let's see in detail how it works. 3-sodium ion binds to protein. The affinity for sodium ion is high when protein has this conformation. Phosphorylation is transferring terminal phosphate group to protein pump by ATP. Sodium ion binding stimulates phosphorylation of protein. Phosphorylation causes protein pump to change its conformation. Therefore, 3 sodium ions are released outside. Then, the new shape has affinity for potassium ion. Allow 2 potassium ion on the extracellular side to bind to protein pump. The binding triggers dephosphorylation. Its release of phosphate group causes protein pump to restore its original conformation, which has lower affinity for potassium ion. Thus, potassium ion released into the cell. This cycle repeats continuously.
So, the sodium-potassium pump is important, right?
Yeah, you got it.
Can you explain in more detail why the sodium-potassium pump is so important?
Okay, let's take a look at it. It's such a relief to find that out.
Thanks a lot for clearing that up.
In essence, the sodium-potassium pump is a fundamental component of cellular homeostasis, ensuring that cells can perform their diverse functions effectively.